In this presentation, we're going to look at list entry structure, which is used for creating and maintaining a doubly linked list in Windows, mainly in kernel. Conceptually, list entry is exactly same as the doubly linked list we have seen before. It is just a different syntax. Why I am treating this list entry in a different presentation is sometimes some students have problem with this list entry and containing record and related areas. So list entry is very commonly used in Windows driver code and Windows kernel, mainly the native part of Windows like NTOS kernel and NTDL. Mainly this is used whenever you don't have the luxury of using something like STL or any C++ open libraries like that. So obviously it is a doubly linked list, so it contains forward and backward link. It normally comes in the middle of a structure. I will show you what this means later in the demo. So this is normally used for keeping circular doubly linked list. So there are a couple of inline functions which we're gonna see, which is defined in some of the Windows WDK headers. Those functions treat this list entry as a circular doubly linked list. So in almost all cases, list entry is used for creating circular doubly linked lists. So as it comes in the middle of the structure, we may have to do a subtraction to go to the beginning of the record or the beginning of that particular data structure. So for that we use another macro called containing record, which we're gonna see as well in this presentation. So this is how list entry looks. You have a F link and a B link, just like in the case of a doubly linked list. It doesn't have any other data elements, so we will see how this is managed in a sample. So containing record macro, so this is a seemingly complicated macro for many of my students. So this is it. So we have spent a reasonable amount of time explaining this macro in a previous presentation when we discussed structures and pointers. So I'm not going to explain this particular macro in this presentation. So all you have to understand is this particular macro subtracts the offset of list entry and help you to get the beginning of the structure. So it automates the subtraction of offset of list entry record, and after that you can access any specific field once you have a pointer to the beginning of a structure. As mentioned, it looks complicated in the initial look, but it's a matter of getting used to it. Once you start using it, it's fairly straightforward. You can include wdm.h. I think it was previously in winnd.h. Anyway, this is not very relevant to this presentation because we are copying that structures from the headers in this demo. This particular macro is not very well in line with the C standard, as it dereferences a null pointer right here, but it works for almost all the compilers, and all the operating system has something like containing record and list entry to keep doubly linked lists. So that's why this presentation is important. Now let's go to a demo and see list entry and containing record. I think it is a little bit too early to do this, so I will skip this part of the demo for a later presentation after a formal introduction to WinDebug. So we have the list entry structure here. So this is the list entry which we have seen in the presentation. So this is pretty much copied from wdm.h and ndef.h. So this is not something which I have written. So we're gonna see two functions which is operating on this list entry. One is initialize list head, another is insert head list. So initialize list head, as the name suggests, it just initializes a circular linked list. All it does is it just make the F link and B link point to itself, as you can see here. Very straightforward. After that, I have commented out some of these functions, but you can uncomment these functions and try it yourself if you want. It is very self-explanatory. Also, these functions are documented in the MSDN if you want to have a look. So all you have to do is copy this and paste it in your search engine and go to the documentation if you want to know more about it. But mostly it is self-explanatory from the name of the function itself. So the function which we're gonna see here is insert head list. So what this function is, it will insert a node at the beginning of the list. It's a circular linked list, so beginning and end is pretty much the same. Again, this has a fairly straightforward implementation. We'll debug through this once when we run the program. Next is our containing record macro. We'll see how to use this. This is some important part you have to look at. This is my custom structure. So I have A, B, C and D, and in the middle I have the list entry. So this list entry has F link and B link. So always this is a case. This is what I mentioned before. List entry normally comes in the middle of the structure. So this is in between. It is not at the end or in the beginning. More or less in the middle of the structure. One of the problem here is, or difference here is, unlike the previous linked list or doubly linked list we have seen, the F link and B link of list entry is not pointing to the beginning of the structure. In the previous case it was pointing to the beginning of the structure, if you remember, but that's not the case here. It is always pointing to the list entry in the next node, which means it is pointing right here, not here. But if you are not pointing to the beginning of the structure, it is difficult to access the other elements like A, B and C. So somehow we have to get into the beginning of the structure, or in other words, we have to get the address which is pointing to the first element of the structure or the first field of the structure. That is where the use of containing record comes into the picture. Now let's see how this is being used, which is the most important part. Normally the headless pointer is always a type of this data structure, a pointer to this data structure, but in this case it is a pointer to list entry, P list entry or list entry star for that matter. plist entry is nothing but list entry star. It's just a typecast. So this is another important difference between normal doubly linked list and list entry. The head is a type of pointer to list entry. So this is how you initialize the list head. You do an malloc or any allocation you have available. If it is kernel, there is a different function called xallocate pool with tag. Anyhow, you allocate memory for list entry and assign it to the list head and call initialize list head. So there are two steps. Now the f-link and b-link will be pointing to the list head itself. Now we are allocating our first node here of type myTestList. So this is our actual node, and we are initializing the node here. So whatever value we want to give, we are giving it here, just like in the case of a normal linked list. Then we are calling this function. This particular function, if you carefully look, it's very polymorphic in the sense that it is not receiving any other type other than list entry. So here it is taking the address of the list entry of this particular node, and it is taking the head list. So the advantage is, irrespective of what is this data structure, this function is going to work, because this function has no understanding of this data structure. It is just playing with the list entry. That is the beauty of this particular implementation. I'm continuing that process. Insert head list. Couple of nodes I am inserting. Again, it is plist entry. And I'm just traversing here. In the traversal, as it is a circular linked list, doubly linked list, this is not null, but it is a first node. There is no concept of null here. So if the last node is pointing to the first node, then that is the end of the list. In the case of non-circular linked list, the last node will point always to null. F-link of the last node will point to null. In this case, F-link of the last node will point to head node. And here is the containing record trick comes into the picture. So what I need is to access the element A. So all I have is the pointer to the list entry. I don't have any access to this particular data structure. All I have is the list entry. But using that list entry pointer, I have to access this particular element. That is what I'm doing here. So what are the things I am passing? One other thing I am passing is the list entry, that particular list entry of that particular node of interest. Another is the type. This is not a variable, this is just a type, but this is a variable. This is a pointer to the list entry of the node of interest. This is again not a variable. Don't get confused. This is not a variable, but this is the name of the field of the list entry in this particular structure. So the only variable here is this temp list. This is a name or type. This is the name of the field of list entry inside this type. So it can be very confusing if you have not followed my previous presentation how this containing record works. So if you treat the containing record as a black box, the return value of, there is no return value, it's just a macro. So if you consider the return value or what it represents is the beginning of this particular node. So once you have that, you can access the element. So it's a pointer to the beginning of that structure of that particular node. We don't need this instruction waypoint. Remove that just to avoid confusion. So now let's have a run through this program and see the output. After that we will debug it. It's a very straightforward program. So the output is A equal to 300, 200 and 100, which is the values we are entering right here. Now I'll put a breakpoint here and here. At the moment, if I look at my list head, F-link and B-link is pointing to same location, which is the head node. 0x00261518. So that is a value we obtained from this malloc. And what initialize list head has done is assign that value to F-link and B-link of this list entry. Very simple operation, just creating the first node of a circular doubly linked list. Not much of a complication. So now we have allocated a new node. We got a new node here, 0x00261560, and we have initialized that node. Now we are going to add that node to this list. At this moment this node is standalone. So what we are doing, we are passing the list, so this is a list, and the address of the list entry structure inside this structure. So we are passing the address of the list entry. Please note that we are not passing the address of the node, but inside that we are passing the list entry's address. So I'm going into the insert head list F11. So this is just a link manipulation. We have seen a lot like this before. So F-link, so this is a temporary variable. We are saving the list head F-link. So the current list head's forward link, we are saving it in a temporary variable, and we are assigning it to the new entries F-link, because this F-link has the rest of the link, and B-link of the new entry should point to the list head. Pretty straightforward. The B-link of the F-link, which we got here, is going to be the entry, because this F-link going to be the second node now, and entry is going to be the first node. So the second node's B-link should point to the first node. That's what is happening here. And list head's F-link should point to the first entry, which is a new entry. So here no complication compared to things we have seen before. So coming back, doing it again and again. So I'm adding 3 nodes pretty much. So now if you look at, I can see 3 nodes. After that you can see that the node is getting repeated. So it is only 4 different pointers. The first one is the head itself, which doesn't have a node. Next 3 has a node, and after that the last one is pointing to the head itself. As you can see, there is no ABCD debugger is showing because we are dealing with list entry. Debugger is not aware about the type. So the debugger is not aware about the actual type the nodes represent. So we got one list entry here, the F-link and B-link. This is the first entry. As you can see, I'm skipping here the head node because head node doesn't have a data structure like this associated with it. It just has a list entry. So I'm going to the F-link of the temp list or the F-link of the head node directly. So that is also a list entry. Yes, F-link and B-link, and this is how you extract A from it, as I explained before. So you have to see my previous presentation regarding structures and pointers, because there is no way to debug and understand this as well. Even if you put an F11 here, it's not going to help you to have a substantial understanding of how this particular statement works. You need to see the previous presentation. Or you can treat this like a black box, which most of the programmers does. Give this 3 things and don't worry about how it is getting into A. Just treat this whole thing like a pointer to this particular data structure or that particular type, and you're good. You can just access it like that. And that's it. Let's go back to slides. So we have seen list entry containing record macro and the importance of it. So if you're into some kernel programming or something similar, this is very important. At least you should know how to use it, even if you don't understand the internals of it. So for containing record, I have pointed you to my previous presentation, and we have explained a couple of differences of list entry with the normal linked list or doubly linked list scenario we have seen before. So I really recommend you spend quality time on this if you don't understand. And that's it. Thank you very much.